Humanity has always gazed up at the stars, dreaming of what lies beyond our fragile home. For centuries, Earth was thought to be the only cradle of life in the vast, dark expanse of space. But with each new advancement in space exploration, that view has changed. Today, the question isn't just about what's out there, but where else we could go, where we might build a second home for humanity. Mars has long been at the forefront of this conversation, a tantalizing, nearby world that promises many of the ingredients for human survival. But there's another contender, the distant world of Proxima b, orbiting a star beyond our solar system, far out of reach for now but rich with potential. So, what's the better choice for a second home? Mars, the red neighbor in our cosmic backyard, or Proxima b, the distant exoplanet orbiting in the habitable zone of a distant star? First, let's turn our gaze to Mars, our closest planetary neighbor. For centuries, Mars has sparked our imagination. From ancient civilizations speculating about Martian life to early astronomers mapping its surface, this world has fascinated humanity. And today, it's the site of some of the most ambitious missions ever launched from Earth. The Perseverance rover, for example, is on the ground as we speak, exploring the Martian surface, gathering samples, and searching for signs of ancient life. Mars is also the planet that feels most familiar. Its day-night cycle is almost identical to Earth's, just a little over 24 hours, meaning our circadian rhythms would adapt relatively easily. Mars even has seasons, though they're a little longer due to its more elliptical orbit around the Sun. But while this planet shares some similarities with Earth, it also brings challenges we cannot ignore. Mars, for all its potential, is a harsh, unforgiving world. Its thin atmosphere is composed almost entirely of carbon dioxide, a gas that's poisonous to us. At only 1% of the thickness of Earth's atmosphere, Mars offers little protection from the sun's radiation. And while its landscape might look familiar, rocky, dusty, with a reddish hue, Mars is a cold place with an average temperature of -60 degrees Celsius. There's no breathable air and no liquid water readily available on the surface. If humans are to live there, they would have to bring their own life support systems and water supplies, or find ways to extract resources from the Martian environment itself. Moreover, Mars is bombarded by radiation. Without a magnetic field like Earth's or a thick atmosphere, the planet's surface is constantly exposed to dangerous cosmic rays and solar radiation. This poses significant health risks for long-term human missions, potentially causing radiation sickness or even increasing the risk of cancer for astronauts. And then there's the issue of gravity. Mars' gravity is only 38% of Earth's, which may lead to issues with muscle and bone density over long periods of time. It's still unclear exactly how prolonged exposure to this lower gravity will affect human health. Despite these challenges, Mars remains humanity's most feasible option for a second home. The efforts to send humans to Mars are already underway. NASA's Artemis program is laying the groundwork for deep space exploration, with missions to the Moon that will serve as testing grounds for technology we'll need to live on Mars. Companies like SpaceX have already outlined their ambitious plans to establish a permanent presence on Mars. Elon Musk's vision is bold, to send the first human crew to the Red Planet within the next decade, and eventually create a self-sustaining colony. To make Mars livable, we will need advanced life support systems, sustainable farming technologies, and ways to extract resources from the Martian soil. Concepts like terraforming, changing the atmosphere of Mars to make it more Earth-like, have been proposed, though the technology required to do this is still in the realm of science fiction. In the near future, the first settlers will likely live in sealed habitats, with systems that recycle air and water, while they work on solving the challenges of living on this distant world. But what if we look beyond our solar system? There's a planet orbiting Proxima Centauri, the closest star to our Sun. This planet, Proxima b, lies in the habitable zone, the region around its star where conditions could allow liquid water to exist on its surface. Proxima b is a world that has intrigued astronomers since its discovery in 2016. It's a rocky planet, similar in size to Earth, and its potential for habitability places it at the forefront of the search for alien worlds. So why not Proxima b? It's just over 4 light-years away, which, while distant, is within reach in terms of the scale of the universe. If it has an atmosphere, stable water, and the right conditions, Proxima b could, in theory, support life and could even become a second Earth. But that's where things get complicated. First, Proxima b orbits a red dwarf star, a star that is much smaller and cooler than our Sun. These stars are known for their violent solar flares, which could strip away a planet's atmosphere. Proxima b is also likely tidally locked, meaning one side of the planet constantly faces the star, while the other side remains in perpetual darkness. The side facing the star could be scorched with temperatures too hot for life, while the dark side could be an icy wasteland. This means any habitable zone would likely be confined to a narrow band on the planet where temperatures are stable enough to support life. Additionally, the distance is a huge hurdle. 4.2 light-years may not sound far, but with current propulsion technology, a journey to Proxima b would take decades, at least 80 years with existing spacecraft. The time and resources required for such a journey are almost beyond imagination, making it difficult to even send a human mission. Even with advances in propulsion technology, we're still far from being able to reach Proxima b within a human lifetime. To settle Proxima b, humanity would need game-changing advancements in space travel, self-sustaining technologies, and colonization strategies. Unlike Mars, where we could potentially rely on Earth for resupply, Proxima b is so distant that resupplying a colony would be nearly impossible. Any mission to Proxima b would require complete autonomy, with settlers relying entirely on the resources they bring with them or develop on site. This would require closed-loop life support systems, food production systems that don't depend on Earth, and habitats capable of protecting settlers from radiation and extreme temperatures. So, which world is better for a second home? The technological feasibility of settling Mars in the near future outweighs the distant promise of Proxima b. It's closer, better understood, and we already have the building blocks to start. The journey to Mars, while difficult, is achievable with current space technology. We've already landed robots there, and we're planning human missions within a decade. The challenges are daunting, but they're not insurmountable. Proxima b, on the other hand, offers the potential for a truly Earth-like world, but at a great distance. With today's technology, a mission to Proxima b would take generations, and the planet's environmental conditions are still largely unknown. The potential for habitability is there, but the risks are greater, and the road to getting there remains an uncertain, long-term challenge. For now, Mars stands as the most realistic option for humanity's next home in the stars. Yet the distant worlds like Proxima b remain an important part of our future. As technology advances, who knows? Perhaps one day, Proxima b will be within our reach, a new Earth waiting to be explored. Both planets offer us hope for the future, but as we venture into the stars, Mars will be our first stepping stone on the long road toward becoming a multiplanetary species.